Okay, so we're going to start off with a quotation by Heaviside here. Heaviside had an interesting way of starting off his chapters in electrical engineering by telling little stories. So here we have a story. The following story is true. There was a little boy and his father said, "Do try to be like other people. Don't frown." And he tried and tried but could not. So his father beat him with a strap and then he was eaten by the lions. Reader, if young, take warning. By his sad life and death, for though it may be an honor to be different from other people, if Carlyle's dictum about the 30 million still be true, yet other people do not like it. So if you are different, you had better hide it and pretend to be solemn and wooden-headed until you make your fortune. For most wood-headed people worship money, and really I do not see what else they can do. If particularly you are going to write a book, remember to be wooden-headed. So be rigorous, that will cover a multitude of sins, and do not frown. There is a time for all things, for shouting, for gentle speaking, for silence, for washing of pots and pans, and the writing of books. Now let the pots and pans go black, and let's set to work. It's hard to make a beginning, but now it must be done. So this is where we begin, with the advice of Hall of Heaviside. So we go right back to the origins of science, which bring us to two people, Plato and Aristotle. But first, let's go back to Steinetz. This is the guy who basically we're talking about. He invented the mathematics that allowed a picture and engineerability of electricity that was beyond anything that any of the great mathematicians or scientists or anybody from that era could do. This is about 1900. And then in our next shot, this is the other subject of our talk, is electricity in its wild, pure form. You're looking at about 100-foot-long, 440,000-volt, 1,000-ampere electrical discharge that just doesn't want to go away but continues to grow. These are the things that the electrical power industry was almost brought to its knees on in trying to tap or prevent these type of situations from happening in the electrical system, and Steinetz was the one that figured it out. Okay, the next shot. Okay, now Mr. Whittaker wrote a book called Theories of Ether and Electricity, or the historical representation of the theories of ether and electricity that covers all the scientific work in electricity. It's about a 3-volume set of about 1,500 pages. And if anybody wants to see where all of these ideas came from about the ether and about light and about relativity and quantum, this is the guy that cataloged the whole thing in a way that is just absolutely mind-boggling, right down to the finest detail. You can go through all of Faraday's experiments and Maxwell's experiments and make your own decision from them, because he doesn't make a decision for you. He just simply outlines the history. So you don't have to redo all the experiments of the past 200 or 300 years. So go to the next shot. Okay, now we have Plato. So our method of thinking comes from two people, Plato, and then we have following him, we have Aristotle. So Plato's thinking was to produce schemes more or less independent of existence on the basis of all being, and they were totalitarian in nature. Where Aristotle is the systematic experience of the surrounding universe, truth attained progressively through the work of individual efforts. Now, Oliver Heaviside breaks this down a little further in the concept of natural philosophy. All of these people, Heaviside, Maxwell, Thomson, everybody that we're going to be talking about consider themselves a natural philosopher. It's a mode of thinking that doesn't really exist anymore today. Now, Heaviside broke the natural philosophy down into two terms, those of the vitalists, which dealt with the living world, and that of the materialists, which dealt with the non-living world, which of course is us as electrical engineers. Now we can find the basic beginnings of science out of Aristotle's thought, but it had to be modified by an English Franciscan friar by the name of Ockham in 1350. He broke tradition with medieval thinking around 1350 and can be called the father of modern science. His line of reasoning led to Copernicus, then Galileo and Kepler. The mode of thinking was now how instead of why. Descartes, in the 1600s, continued the line of reasoning and developed the first concept of the ether, which is the most important concept in dealing with electricity. Descartes regarded a metaphysics beyond the physical. He called it the last part to be studied, as it is necessary to have previous knowledge of many things. The study of electricity, considering the electric phenomenon as non-physical, is hereby, by Descartes' reasoning, a metaphysical and not a physical study. And this is the center of the whole problem. Electricity is not a place for physicists. Okay, now Erasmus in 1509 gave a basic description of pre-Descartes thinking, which basically is where we are back again today. He said, there are innumerable niceties concerning notions, relations, instants, and formalities, which no one can pry into unless they have eyes that can penetrate the thickest darkness, and there can see things that have no existence whatsoever. The very state that Erasmus complains of in 1509 has been reborn in the concepts of relativity and what I refer to as quantum mysticism. Tesla states, the scientists from Franklin to Morse were clear thinkers and did not produce erroneous theories. Scientists today think deeply instead of clearly. One must be sane to think clearly, but one can think deeply and be quite insane. Today's scientists have substituted mathematics for experiments, and they wander through equation after equation and eventually build a structure which has no relation to reality. That's a pretty heavy statement for Tesla to make. Now, Edwin Armstrong, after being ripped off by RCA for his FM invention, really summed up the concept the best with the phrase, they substitute words for reality and then talk about the words. Heaviside gives his idea on what science is really about in his era, and very complicated statements. There is no self-contained theory possible apart from practical meaning. For a language is used in its enunciation, which implies that developed ideas and complicated processes of thought are already in existence besides the general experience associated therewith. We define things in a phrase using words. These words hail to be explained by other words, and so on forever in a complicated maze. There is no bottom to anything. We're all antipodians and upside down. The misinterpretation of J.J. Thomson's discovery of the electron greatly hampered the understanding of electricity, and in 1900, Steinetz summarizes the situation in one of his books. He says, unfortunately, to a large extent in dealing with the dielectric field, the prehistoric conception of the electrostatic charge on the conductor still exists. This destroys the analogy between the two components of the electric field, the magnetic and the dielectric, and make the consideration of the dielectric field unnecessarily complicated. In actuality, it eliminates the dielectric field and makes it so that you can't calculate it and substitutes electron flow in its place. Wires are not conductors of electricity. This misconception of so-called conductors or wires carrying electricity like water in a pipe was continuously attacked by Heaviside in his writings. The entire article is written on the matter titled A Perfect Conductor is a Perfect Obstructor, but does not absorb the electromagnetic energy of the waves. Heaviside states, it was discovered by mathematical reasoning that when an electric current is started in a wire, it begins entirely at its skin, in fact upon the outside of the skin, and that, in consequence, sufficiently rapidly impressed fluctuations of the current keep to the skin of the wire and do not sensibly penetrate its interior. The concept of electron flow in wires rather than electrical field flow around the wires can be related to seeing the footprints of the invisible man in the snow. Heaviside says now, very few, if any, mathematical electricians, he's writing this in about 1890, very few, if any, mathematical electricians can understand this fact. Many of them neither understand it or believe it. Even many who do believe it so do not because they are told so, I believe, simply because they can in the least feel positive about the truth of their own knowledge. An eminent practitioner remarked after prolonged skepticism, if Sir Thomson says so, who can doubt it? What a world of worldly wisdom lies in that remark. That's Heaviside's quote. The relativists, with their concept of distorted measurement, or curved space, replacing an ether, and their concept of the equivalency of matter and energy worked great harm into electrical sciences. A post-Maxwellian theory of electromagnetism was to prevail, ignoring the works of Tesla and J.J. Thomson. Tesla states, "For more than 18 years I have been reading treatises, reports of scientific transactions, and articles on Hertz wave theory to keep myself informed, but they've always impressed me as works of fiction. Energy-matter equivalency, as propounded by the relativists, serves to distort the proper understanding of the continuity of energy as represented by Heaviside. The false doctrines of the law of conservation of energy has a deleterious impact on the findings of Steinetz and others that electrical energy can be synthesized." Relativism sought to eliminate the concept of electricity in its entirety through the denial of the concept of the ether and plunged science into a giant glut of Platonic thinking and thereby established a type of religion called quantum mysticism. It seeks the creation of a spiritual entity, such as a goddess, in which to engender its framework of thinking. The influence, somewhat forceful, of the British thinking on science has been also a serious impediment upon the growth of electrical science. Foremost was the British Association, establishing a distorted system of units, ohms, farads, and what have you, representing electrical quantities. The effects were disastrous. Arbitrary factors such as 4 pi or the speed of light squared stuck to the electrical units like crap on shoes. The relativists took these parasitic factors, which have no meaning in real terms, and fabricated an entire way of thinking out of them. Heaviside used the phrase, "the brain-wasting perversity of the British." Euler describes British thinking on gravity as, "The English maintain that attraction is a property essential to all bodies, mutually to approach as if they were impelled by feeling. Other philosophers consider this opinion as absurd and contrary to the principles of rational philosophy." What was happening is the British were trying to say there was nothing in between the objects that attract, such as magnets, that it was purely the bodies themselves, and space in between was void of any acting material, which has to be complete nonsense if you're going to deal with electricity. That's where the ether comes in. English natural philosophers such as J.J. Thomson totally ignored the work of Americans such as Tesla. In fact, racial and national conflict played a major role in what would be established as scientific thinking. Nollet of France would rail upon the works of American Ben Franklin, the grandfather of modern electrical science. The French would enrage the English with their ideas on Newton, and hereby the English abandoned the ether concept for action at a distance in reprisal. Maxwell was to predominate over Helmholtz. The important works of Goethe and Steiner, who came up with a completely complementary concept of electricity and matter and these things that the British, through Newton, were working on, were completely ignored by the British and Newtonian thinking, even though the works of Steiner are extremely important in understanding certain electrical relationships. Racial mysticism such as Nazism or Zionism has given the world today a twisted nuclear thermodynamic science, producing a divergent culture racing towards destruction. Steinmetz regarded the Maxwellian concept of the transformer a fantasy. In fact, modern physics representation of transformer action is the diametric opposite of that of reality. In the manner of Heaviside, let us tell a story. The story is entitled An Explosion at the Shipyard. Enough. Heaviside laments. The question is what now is to be done? Are we modern pygmies who by looking over the shoulders of the giants can see somewhat further than they did, to go on perpetuating their errors forever and ever, and even legalizing them? Upon the general acceptance of Einstein's relativity, Oliver Heaviside painted his fingernails pink, removed all the furniture from his house, and slept on a block of stone, and wrote no more. Okay, that's the completion of the first part. Are there any questions? Okay. So now we're going to get into basically what Steinmetz is about. And this, towards a correction of this type of problem, stepping on toes as one goes on, which is basically the air of this particular talk I'm giving. This might be the conversion from Heaviside to Michael Savage. To quote Heaviside, This seems strong language, but as Professor Tate tells us, that it is almost criminal not to know several foreign languages, which is a venial offense in the opinions of others. It seems necessary to employ strong language when the criminality is more evident. It must be severe and logical. This is why Heaviside was eventually banned from writing, at least for a while. Upon giving up, Tesla states, "I am unwilling to afford to some small-minded and jealous individuals the satisfaction of having thwarted my efforts. These men are to me no more than microbes of a nasty disease. My project was retarded by nature and the world was not prepared for it. But the same laws will prevail in the end and make a triumphal success." I think you can see from the beginning of my talk that none of these people are very happy. Has anybody got that idea?
If you mix Mike Savage and physics, that kind of get the idea.
What's that?
If you mix Mike Savage and physics, that does get the idea.
Okay, so now we're going to get into Maxwell, Heaviside, and Steinetz, and how the electrical process was picked up by them. For 2,000 years, as Mr. Whitaker tells us in his book, the attractive power of amber had been regarded as a virtue peculiar to that particular substance, or possessed by at most one or two others. Amber being where you rub the material and it picks up the little pieces of paper, the original electrical experiences of the Greeks. Gilbert proved this view to be mistaken, showing that the same effects are induced by friction in a quite large class of bodies. A force which manifests in so many different kinds of matter seemed to need a name of its own, and accordingly, Gilbert gave to it the name electric, which it has ever retained. So the birth of the word electric then became established in 1646 AD. Michael Faraday, in 1831, makes public his theory of an electrified ether consisting of polarized corpuscles forming tubules of electric induction. He begins this study of the analogies between motional and statical electrical currents. Here begins the science of electricity. James Maxwell, in 1855, at the conclusion of Faraday's research and development of the contiguous ether concept, sets out to construct a mechanical model of electrodynamic actions. He wrote, "By careful study of the laws of elastic solids, the motions of viscous fluids, I hope to discover a method of forming a mechanical conception of this electronic state adapted to general reasoning." It has been said that Maxwell put the math to Faraday. The impact that Maxwell's ideas had on the emerging electric science was truly profound. Utilizing the recently developed ideas of Newton, Leibniz, and Hamilton, Maxwell produced a mathematical concept of electricity, one that stands to this day. Oliver Heaviside, in 1895, begins to publish a series of articles titled On Electromagnetic Induction and Its Propagation. Here Heaviside develops what he calls electromagnetic theory from the Faraday-Maxwell point of view. By 1888, Heaviside was banned from publishing through the efforts of a Mr. Preece of the British Post Office Telegraphy Administration. Heaviside was called a disgrace to the Royal Society. However, Oliver Heaviside established electrical engineering as we know it today. Heaviside finds that the Maxwellian ideas are so cumbersome and overly mathematical. A mathematician himself, Heaviside begins development beyond the concepts of Maxwell. Heaviside states, what is Maxwell's theory? Or what should we agree to understand by Maxwell's theory? The first approximation to the matter is to say, there is Maxwell's book as he wrote it. There is his text, and there are his equations. Together they make his theory. But when we come to examine it closely, we find that this answer is unsatisfactory. To begin with, it is sufficient to refer to papers by physicists written, say, during the 12 years following the first publication of Maxwell's treatise to see there may be much difference between the opinions of them as to what the theory is. It's seen differently and by different men, which is a sign that it is not set forth in a perfectly clear manner and unmistakable form. There are so many obscurities and some inconsistencies. Speaking for myself, this is Heaviside speaking, it was only by changing its form of presentation that I was able to see it clearly. and so as to avoid the inconsistencies. Now, there is no finality in growing science. It is therefore impossible to adhere strictly to Maxwell's theory as he gave it to the world, if only on account of it being inconvenient in form. But it is clearly not admissible to make arbitrary changes in it and still call it his. He might have repudiated them utterly, but if we have good reason to believe that the theory, as stated in his treatise, does require modification to make itself consistent, and to believe that he would have admitted the necessity of the change when pointed out to him, then I think the resulting modified theory may well be called Maxwell's. This is where Heaviside began his 1,500-page book called Electromagnetic Theory, which is basically the icon of electrical theory and science. Everything today basically rests on it. Heaviside published his 2-volume work called Electromagnetic Theory. It went to 3 volumes in 1892. Here he developed his reconfiguration and extension of the Faraday-Maxwell concept of electricity. Most terms used by electrical engineers, such as impedance, find their origin in these volumes. Oliver Heaviside developed a complete and verified theory of propagation of electric waves on telephone and telegraph lines. The brilliance right out of abject ignorance met with harsh opposition. But when AT&T developed the first long-distance lines on Heaviside's theory, the voices of the opposition were silent and their noses went high. By the Maxwellian concepts of Oliver Heaviside found institution in the telephone and telegraph industries, there were certain difficulties in the application of these concepts to the electric power transmission systems, particularly with regard to waves and transformers. By 1900, Charles Proteus Steinetz had presented his theory of Versor operators to replace the cumbersome differential equations utilized by the followers of Maxwell. Steinmetz was severely criticized, notably by Michael Pupin, who had glommed on to Heaviside's principles for AT&T, never mentioning Oliver, of course. However, Steinmetz's method was now a resounding hit amongst electrical engineers who now could forge ahead with Tesla's new system of alternate currents. This mathematical methodology thus allowed the extension of Tesla's AC technology throughout the world. Steinmetz quickly became an ultra icon of the United States of America. Heaviside began development of a similar line of thinking 30 years earlier with what he called his impedance operator. This concept, while replacing differential equations, was still too cumbersome for electrical engineers. In addition, it was Maxwellian. The Steinmetz method, being specialized for continuously alternating waves, was of such simplicity that one may get the feeling of cheating or such. In the corporate world that Steinmetz worked his concepts of Versor algebra in, as it is called, let's see, I think I skipped something here. He could never advance it as far as he might take it. The companies were not interested in math, they were interested in machines. While attending a paper presented by Michael Pupin on the Tesla induction motor, Steinmetz remarked that the differential equations made it too mathematical for practicing engineers. He quickly sketched on the blackboard his complex number theory, which was simpler mathematically and also accounted for the losses. Not possible in Maxwellian terminology. Upon finishing, Steinmetz was criticized for not using Maxwell coefficients by Pupin. Steinmetz disliked the Maxwell approach because the coefficients of mutual inductance were expressed in a combined form as one magnetic field, where in actuality, in transformers, they exist in two fields, in what Steinmetz calls the mutual flux and the leakage flux. This conception is of utmost importance and serves as one of the main themes of this paper. So Steinmetz was given credit for being allowed by his employer to create electricity from the square root of -1. And this is where we enter the basic theory of the talk. Is it possible to synthesize electrical energy? So, a Vladimir Karapetov, professor of electrical engineering at Cornell University, expressed that Steinmetz was allowed by his employer to create electricity from the square root of -1 at the eulogy of his death in 1923. This appeared in the Cornell Daily Sun on the 29th of October, 1923. Before the Steinmetz method, engineers had used differential equations or graphics to calculate alternating current problems. Engineers could see the alternating electric wave with crystal clarity. In this view, a few engineers knew that electrical energy can be synthesized, literally created along certain lines of mathematical reasoning. At a lecture at the American Institute of Electrical Engineers, in which Steinetz, Tesla, and others threw their ideas back and forth about these, Professor William Anthony stated at the closing of the meeting that within 1 year they were going to have a self-sustaining electrical system that didn't need any fuel. This was in the 1890s. Where is it today? Steinmetz began study of what's called synchronous parameter variation. The meaning of this is the variation of energy storage coefficients, such as inductance or capacitance or resistance, with respect to a point in time on the AC cycle, is the cause of what Steinmetz says, is caused by what Steinmetz says, the lack of uniformity and pulsation of the magnetic field, causing a distortion of the induced EMF at open circuit as well as under load. The pulsation of reactance causing higher harmonics under load. He's speaking about generators and motors now. The pulsation of resistance causing the same harmonics. That was the big flame you saw at the beginning, leaping off the disconnect switch. Now, the normally constant or time invariant coefficients change in value with respect to time. Now we have a peculiar set of dimensions of henries per seconds, ohms per seconds, farads per seconds, and Siemens per seconds, and this is where the concept of the law of conservation of energy comes apart, because the energy is appearing and disappearing in these relationships without any equality or connection anymore. Energy could either vanish or energy could appear in the system. Steinmetz states in Article 241 of his Theory and Calculation of Alternating Current Phenomena, published in New York in 1900, the following. We find here a case of a circuit in which the power factor, that is, the ratio of watts to volts amperes, differs from unity without any phase displacement in the phase of the cycle. That is, while the current and the EMF are in phase with each other, but are distorted, the alternating wave cannot be replaced with equivalent sine wave, since the assumption of equivalent sine wave would introduce a phase displacement of an angle that doesn't exist. This condition made itself apparent in the line switching equipment of the primordial electrical industry. Let's see if we have some of these. Now, this is a prime example of what happens. Okay? We're trying to turn off a 220,000 volt power line, and this is the switch. It stands about 50 feet high. Now, what they've done is, in order to eliminate the oil tanks, which normally break the main discharge, they're using vacuum columns. And what it is the mechanism breaks the circuit inside the vacuum columns. But being that there's no gas or oil or anything to carry the current through to the zero part of the cycle, the voltage tends to,
That's your laser.
the voltage tends to raise to infinity, trying to maintain the power flow. This is where the switches start to explode as they're opening here. Now, normally, these cells here break the electrical circuit in the vacuum so there can be no arc, but that's kind of the last thing you want to do, because the momentum of the electricity will come thundering back down the line to try to keep it going. And what I just read from Steinmetz is in the actual arcs where the switch contacts are breaking open, is you start to get energy anomalies in these arcs. And the system goes into a cumulative oscillation and continues to accumulate energy until something blasts. So as we go through the opening of the switch, you can see where now the fire has jumped across and there's no way to stop the flow and it's just accumulating. I think we've got one more shot before it explodes. There we go. Now it's getting ready for the final blast, and then the final shot, that's another switch. Okay. That's the final shot where it shorts out the power line. The intensity of the light's so great that the camera can't really, it shorted out the camera. So you can't really see you can't see it at this point very clearly. It fuzzed it out, but that's a lot of power there. You're talking about the electrical discharge there is probably equivalent to maybe 20 locomotives running full bore, hauling trains over the Tehachapi Pass.
But I'm sorry, I just want to get this right, because it's interesting. A plasma is established inside these vacuum switch chambers?
No, the whole idea is to have no plasma.
Right.
But being that the current is not cut off at a zero point in the cycle, as the electrical momentum starts to come thundering back down the line to maintain the current.
So a plasma is created in this process?
No, inside it does not create a plasma, but the problem is the voltage gradient goes so high. Can we go back to the first one? When it first starts to blow. Okay. What happens is it's the voltage gradient now, the electric field around this. We'll get into it later. This is not just objects in isolated space.
That's
right.
fine.
The electric field density has become so severe, okay, that it has to strike out in the atmosphere to create a plasma because it can't create it in the switch. So you might have an electrical field here in the order of maybe 10 or 15 volts per megavolts per centimeter. And so the fire breaks out. See, normally when the switch opens, the remaining fire is dissipated in these opening arms. As you see going through the video, it goes step by step. These were live pictures, but we couldn't have they're stunning to watch move. So you can see now the arcs have come off the switch and now found their way back to the line terminals. And there's no way to stop this now. And then the arcs are changing resistance. This is the key thing. The arcs are cyclically changing their resistance with respect to time on the alternating current cycle. And in the process of doing this, they're creating a imaginary, or I wouldn't say imaginary, but another dimensional energy that has to come out into this dimension. And this is a process very worthy of study. This is what Steinetz is mentioning here in Article 241.
Then I would like to, one thought, because a lot of folks keep getting, like Art Bell, for instance, keep getting these mysterious voltages occurring on their antenna arrays, is that related to this concept here?
No, not directly.
But it does indicate that there's something else coming in from a different dimension set, maybe.
Well, what it is basically mutual induction to the ionosphere and the sun. And those electric fields are always changing, but it is an electrical gradient. But there's no plasma other than the sun itself. But then we're getting into a system of much larger dynamics and more factors come in. Right. Okay, so let's see. Okay, the condition made itself apparent in the line switching equipment of the primordial electric industry. Large transmission lines and substation transformers refused to be de-energized without some large fire or blast. This is a substation going up when they couldn't turn it off. So three shots here. So this is what they were dealing with, and it wasn't a happy situation, and they had no way to stop it. If you tried to turn the stuff off, this is what would happen. And people got unfriendly about it, not alone the people that paid for it. The condition, it was not as if they were creating their own energy. Let's see, I left off something here. AC power distribution could not progress because of this condition. It was as if they were creating their own energy, and this energy would not appear on the switchboard instruments of the power system. Energy now had a new meaning, and engineers felt a new era in the process of making. This is when Steinetz wrote his next famous book, was on this topic. Situation came to a head to a crisis level for both GE and Westinghouse, who were pointing the fingers at each other that their line switching equipment was, the other guys was bad and theirs was good. And they couldn't share the deal, so when the whole thing blew up, they had to start pointing the fingers. So what happened is the electrical system for the Manhattan Elevated Railway is what we're talking about. So the Manhattan Elevated Railway blast and ensuing shutdown in 1903. At the time, it was the world's largest steam-driven electrical generating plant. The capacity was 40 megawatts with a voltage of 11,000 volts from phase to phase. Singing static discharges of surge arresters began at one railway substation, and then at another railway substation. Shortly afterwards, a massive underground blast raised the street around the splicing manhole. Many of the 5 megawatt alternators suffered damage. Upon analysis by Steinetz, it was that a progressive or cumulative oscillation had developed, evading station voltmeters. This oscillation cohered at 270 cycles a second in the entire electrical system with a wave crest of 120,000 volts. That's a lot of buildup over 11,000 volts. And the final fault current was a fault current of 9,000 amperes. So we're talking about a pretty good bang. That's why the whole street lifted up 2 or 3 feet. Out of this work, Steinetz developed the synchronous condenser, a type of dynamotor that one may be tempted to call a free energy device. This machine is utilized by the utility companies to provide part of the power to their transmission system that would otherwise have to be produced at the distant generating facility and thereby cause a waste of power in its transmission. So basically, the electrical power industry is in a certain sense already using so-called free energy concepts because it's inherent in the distribution system itself when it gets to a certain size. And we're using the synchronous condenser, which is a very large synchronous motor that's immersed in hydrogen gas. The reason it's immersed in hydrogen gas is to cut the windage down, and hydrogen is a heavy absorber of heat. So they can keep the machines cool and they can keep the windage losses down. The motor only connects to itself electrically. And through this synchronous parameter variation, what this motor does is become a generator by working its own phases inside, and supplies all the magnetizing power for the system necessary to keep the transformers and transmission lines magnetized. And between the synchronous condenser and the substation at the distance end, through my experiments, I've determined that energy is actually synthesized in the space between the wires in the magnetic field. Now, I did an experiment with this when I was at the Richmond shipyard, exerted by dielectric lines of force between two bodies. Now, Thomson felt, unlike Faraday felt that the lines were magnetic, but Heaviside and Thomson felt that the dielectric were the primary and the magnetism was just that circling around the dielectric. You know, it's kind of like a chicken or egg consideration that's never really been fully resolved because the ether has no tangible physical dimensions. Okay, now what's happening is these lines of force tending to be contractive pull the plus and minus together. And this basically is a representation of the process of attraction. Now we go to the next one, we have the process of repulsion. So in the process of repulsion, we don't have lines of force pushing the two objects apart. What it is the lines of force now have to terminate on more remote surfaces of molecular dimensions. And what it does is it pulls them away rather than pushes them away. So the repulsive process is not really a pushing apart, it's a pulling apart. And there's a void here in the middle of the absence of electrification rather than a concentration of it. Okay, now Euler's ether, and one which was prescribed to by Tesla to compensate for, or to give an idea of gravity, that's further down the line here. We'll just cover that one briefly because it's specialized. Okay, now both Euler and Tesla felt that there was a type of gas where the mean free path of the particles was so intense because of their extremely high velocity that they would never hit each other in any fathomable distance through space. In other words, they could go for light years through space without hitting each other. It's a peculiar type of gas. Tesla confirmed the existence of these particles, which he called his cosmic rays, which are not really connected to the cosmic rays as they're told today. He had discovered a primary type of cosmic ray, which he said moved at 50 times the velocity of light. Now, what these guys all thought is that what gravity is, because it's not just simply two things attracting, something has to make them pull together. And we saw by the lines of force that what appears to be pushing apart is really pulling apart. If we look at it this way, is if these randomly moving ultra-gas particles strike an object, many of them will go right through. Like these rays can be detected in the deepest mines of the world without suffering any attenuation. They can go right through the planet, but a certain amount of them will hit something. Now what happens is that creates a dead zone. So now you no longer have a uniform pressure of impacts around the object because the mean free path is so extreme that what it does is now this void zone, you have more lines pushing here and more lines pushing here than you do here or here. And this is what causes objects in space to move towards each other, is they're actually pushed externally. It really is the most sensible view of how gravity operates. But it leads to some conclusions that are very unpopular. Because by this type of theory, all of the planets and the sun have to be hollow. And people don't like to talk about that. So Tesla also regards the ether as a gas and succeeds to produce these ultrafine high-speed particles in his vacuum tubes. Now I've duplicated this in an experiment. He claims velocity is 50 times that of light. Tesla's tubes gave the ether the properties of mechanical force against ponderable matter. I'll describe an experiment I did So I took these special Tesla type of currents that we'll get into later why they're different, and energized light bulbs with them. Well, the light bulbs don't light up like normal on this because this is not normal electricity. So this kind of solar system or galaxy starts to appear inside the bulb with little suns and comets and stars, and gradually becomes cumulative like these power line oscillations. And what happens in this process is that actually, even though that the bulb has a vacuum or partial vacuum in it, is the glass, when heated, starts to push out. Something is pushing the glass out. So what has been done is the ether now has been solidified into something that can exhibit physical force against matter. Now when, has you got a screw up there? I'll wait till the screw up's over.
I'm sorry, what?
Oh, the one with the lights blinking and you guys are talking, so.
Next slide?
Did something, no, I just thought you had a problem.
Yeah, well, just with the videotape.
Okay.
We're still rolling over here.
Okay, so what happens is this entity inside the bulb produces so much impact and heat on the glass that when it melts, it'll melt a hole in the bulb. Now, you would think when a hole is melted in the bulb that the air would rush in and wreck the partial vacuum and the bulb would cease to work. Well, it's the exact opposite. What happens is this purple ether comes shooting out of the hole like a little air compressed jet and hisses, and the vacuum in the bulb becomes stronger. So this completely turns the concepts of what's inside empty light bulbs inside out. Steinetz regarded the existence of the ether as a reality, but changed horses when the concept of the ether was eliminated by the Einstein concept of distorted measurement of what is called relativity. A natural philosopher by the name of Lamore, at this point, says we should not be tempted towards a simple group of relations, such as Maxwell had tried to create, which have been found to define the activity of the ether by treating them as mechanical of concealed structure in that medium. We should rather rest satisfied with having attained their exact dynamical relations and not be into describing a physical, because they're not physical. Okay. Now, it looks like I've run out of material.
Wow. That looks really cloudy. See how opaque that is? Oh, and look, it's got the bands. Oh, it's got some really neat stuff in the top. Oh, see that? I don't know if you can see it from your angle, but it made like a really thin band. Oh, yeah, right there. Oh, that's cool.